So now we're going on to question 3, which is one with the PERT chart. So hopefully this is quite a straightforward question, although it does take a bit of time to work through. So we have this table of tasks involved in carrying out a project, and often you don't really need to look at what the tasks are, just what each task precedes, and preceding tasks and how long each task takes, which is called the duration. So the first step would be to fill in the task on which task goes in which box, which is you may have done this at National 5 applications of maths. We can see task A is the initial task, then tasks B, C and D all depend on task A. However, we don't know which one is which, especially because of this branch, which has 2 on it. So sometimes you just start where you can, fill in what you know, and then look at what's left. So looking at later, we can see tasks F, G and H. They all depend on the same things, and they all can take place in parallel. So they will be the 3 tasks later on. They will be F, G and H. We can see the task I depends on F, G and H, so that's the one that follows on. And finally task J is the one that follows on from task I. So maybe next we'll look at which which tasks could be the single task that is between A and F, G and H. So you can see that task B has a preceding task of task A, and also F, G and H, they depend on task B. So that task B can go in that first box because it's on the branch with only 1 in it. We can see exactly the same thing for task C. Task C is a preceding task for task F, G and H, and also it depends on A. And that means that its task D has to be the one on that middle branch. So that is all the tasks filled in, which task goes in which box. The next step would be to copy over the durations, and they will go in the middle boxes, and we simply copy those over from the table, and it would look like that. Now we do the forward scan and then the backward scan. The forward scan is from left to right, and we use that to fill in the first box for each task, and that tells us the earliest possible time each task can start. So we always start at 0, in this case it's 0 hours, and then we work forward. So 0 plus 2 is 2, so now tasks B, D and C cannot start until after 2 hours. We can also do task E by doing 2 plus 8 is 10. To get the early times, as we call them, for task F, G and H, it is slightly more complicated. We have to look at tasks B, E and C and see when can they finish. Well, task B has to start at earliest at 2 hours and will take 12 hours. The task B will be finished at the earliest at 14 hours. Task E will be finished at the earliest at 14 hours. However, task C will be finished at the earliest at 26 hours. So when we are doing the forward scan, we always take the later or latest possibility. The early time for task F, G and H will be 26 hours. Now, getting the early time for task I follows the same principle. Task F has finished or can finish at earliest at 40 hours. Likewise for task G, that could finish at 38 hours. Task H could finish at 32 hours. So the latest of those is the 40 hours. So the earliest possible time task I can start is 40 hours. And then the earliest time that J can start is 46 hours. So now we do the backward scan, and what this fills in is the latest possible time a task can finish without the entire project being delayed. So it means it allows the project to finish within the shortest possible timescale. So the shortest possible time for the project would be when J finishes, and that's at 46 plus 8, and that would be 54 hours is how long the entire project would take. So now we start with 54 hours and work from right to left. 54 take away 8 is 46. So the late time for task I is 46. 46 take away 6 is 40. So the late time for tasks F, G and H is 40. Now it gets slightly more complicated because we have multiple possibilities to check. Task F has to start at 26 or by 26 hours, otherwise the project will be delayed. Task G has to start by 28 hours, and task H has to start by 32 hours. Now, we always take the smallest of these on the backward scan, 26 hours. So the late times for tasks B, E and C will all be 26 hours. We can get the late time for task D by working backwards and doing 26 take away 4 is 22. And finally, we can get the late time for task A by doing checking all. You could say you check all the possibilities: 26 minus 12, 22 minus 8, and 26 minus 24. The smallest of those is 2. In some cases, the numbers add up. So, for example, looking at task A, from left to right, 0 plus 2 equals 2. And in task C, 2 plus 24 equals 26. The tasks where that happens are on the critical path, which means they cannot be delayed without delaying the entire project. In other words, they have no float time. So that's one thing to check that you've done this backward scan process correctly. However, you can't just always add the numbers up. So for example, if you look at task D, 2 plus 8 is 10, not 22. So that does not work for all your tasks. So now on part B, we are constructing the Gantt chart, which again should be a very routine process to follow. So we start by putting in labels down the side. Make sure you have enough space for everything, but there is just about enough space. Then we'll start with task A. And I say look at the durations. That's probably the easiest way to do it. The task A has a duration of 2 hours, and if we look at the scale, we see it's going up in twos. So that means we'll shade in one box for task A. On B, it's 12 hours, which is 6 boxes, so we shade in 6 boxes. Task C will start at the same time as task B, and we go in total to 12 boxes. Don't worry about, so I think I miscounted, but 12 boxes in total. Task D is 4 boxes to represent the 8 hours. Now you'll notice that task B, C and D all start at the after 2 hours is finished. Task E, however, follows on from task D, so it doesn't start until after 10 hours, and that is 2 boxes, 4 divided by 2. Now tasks F, G and H, they will all finish after task C is done, and that's beginning at after 26 hours. What many people find confusing about these Gantt charts is the scale, because for whatever reason they like to put the numbers in between the lines rather than on the lines as you would usually expect. So I sometimes like to think that, for example, that 26 is written underneath the line in between the 26 and the 28, and that makes more sense to me. The task F is 7, so if it's 14 divided by 2, so shade in 7 boxes. Task G we shade in 6 boxes, and task H we shade in 4 boxes. Finally, coming on to task I, you can see from the PERT chart that begins at 40 hours. So on the scale at 40, it's starting after 40 is completed. Again, you could imagine the 40 is just underneath the line rather than the space. And we shade in for 3 boxes for task I to represent 6 hours. And finally, task J, we shade in 4 boxes. And we can see that is finished after 54 hours in total have passed. Question C is one where you have to state what the critical path is and the minimum time for the job. So the minimum time for the job you can read directly off the Gantt chart or the PERT chart. At final time is 54. The minimum time for the job, 54 hours. The critical path, as I said earlier, you get by looking at the tasks with no float time. So task C, 2 plus 24 is 26. The task takes exactly 24 hours to do. It has to start by 2 hours, or the earliest it can start is 2 hours, I meant to say. And it has to be finished by 26 hours. So there's no time for any delays on that task. Likewise, task F, 26 plus 14 is equal to 40. So it's a critical task. The other tasks, tasks B, D, E and H, are not critical. They still have to be done, but they're not categorized as critical. And to determine the critical path, to state your answer, you would simply list the tasks in order. So part D is one you have to read carefully. It says determine the maximum time that can be taken to disconnect the propeller shaft. And disconnecting the propeller shaft is task H. So it wants the maximum time that task can take. But looking at task H, it has to, at the earliest it can start at 26 hours if everything before it is done on time. It has to be finished by 40 hours. That means you've got 40 minus 26 hours. So 14 hours is the time available to do task H. What possibly some people might be confused by on this question is that they might think you have to work out the float time. But that is not asking for the float time, it's asking for how much time is available to do the task.